My name is George Crump. I'm the lead analyst and founder of Storage Switzerland. We are an analyst firm focused on the storage, server virtualization, and cloud computing marketplaces. We provide education and information to end users on new and emerging technologies and how to best use those in their data center. Today, the benefit to data centers in using solid-state storage is a very niche use case, typically almost always database application. For increased adoption to occur in solid-state storage, we need to broaden the use case across more than just these very high-end revenue-generating applications. The next step in solid-state deployment, and probably the most logical step for most users, is to accelerate block-based storage. What makes XLSAN unique is that it works on block I/O devices, which is great because that's exactly where the data is that we need to accelerate. Storage managers who are looking to accelerate a broad range of applications should consider XLSAN. It allows them to deploy the technology across all applications, not just the few that are revenue generating and things like that, but anything that could see a performance boost. So high-end databases, mid-range databases, server virtualization projects would all benefit from a product like the XLSAN solution. XLSAN provides complete investment protection. It allows you to see a performance boost across your entire storage portfolio without having to upgrade software or buy new hard drives or anything like that. The other big advantage is that that investment is also amortized across a broad range of applications. Instead of just a few, every application gets to participate in higher performance, and that really allows for a quicker return on the investment. Thus far, what suppliers have tried to do to enter into the solid-state market is to leverage technology where flash storage has been packaged into something that looks like a hard drive container. The downside, though, from a user perspective, is that now you have this device that was really designed to handle a pretty slow mechanical drive that's now handling a very fast, latent-free technology. And memory wasn't necessarily designed to be put into a drive and put into a shelf. What traditional storage manufacturers are trying to do to solve the issue of a solid-state tier that's updated once and then never updated again is they're developing automated tiering technologies that will dissect the data, and then as it becomes popular, automatically move the data into that tier, and then if it becomes unpopular or less accessed, it'll move it back down to a hard drive tier. Some of the shortcomings of automated tiering is that you have to move data back and forth between the tier, and so you're copying large chunks of data up into solid-state storage, and then later when something else becomes popular, you're copying something else up. Well, the last thing you want to do is do something that takes away from that performance. The other challenge with automated tiering systems is that thus far what we've seen from suppliers is that they all write new writes to the mechanical tier first. Well, writes are the most expensive from a resource perspective operation that a storage system has to do. So what happens then is that data is written to this slower tier and then over time gradually promoted up. Well, that's a waste of resources. It makes more sense to write it to the solid-state tier first, but we don't see suppliers doing that at this time. IT managers can implement tiering in their existing storage hardware, but that's going to require a software upgrade. So A, you have to make sure that your storage supplier is going to come out with automated tiering, and then B, you have to schedule time to do that upgrade. This will be a significant upgrade, and that means you can probably count on some level of downtime and maybe a significant level of downtime as you do this upgrade. As an alternative to automated tiering technology, there is the ability to use caching appliances. The big advantage to caching appliances is, first of all, they install relatively painlessly. They can just go right in front of storage and they can accelerate a broad range of applications that are on the storage behind them. The other big advantage is you can leverage existing storage and not have to necessarily upgrade your current storage systems or wait for your current storage systems supplier to come out with a new upgrade to their device that has automated tiering. Caching appliances are also more efficient than automated tiering solutions because they're designed from the scratch to be using solid-state storage. There's a significant performance boost in using advanced caching because they accelerate writes instead of just reads. So this means that the most expensive operation that the storage controller has to perform, a write operation, is now finally accelerated. It also means that the moment the cache is installed, the customer will see an instant performance boost because as they write new data, it's being cached. There's no warm-up time that we have to suffer through. Data centers are looking for ways to fully take advantage of solid-state storage. If you look at the options that are available to the storage manager today, products like AcceleSAN are really where we're heading from a technology standpoint. The ability to accelerate across the board, to do so easily without disruption to current systems, and probably most importantly, to continue to leverage your existing investment, just make it faster.